Okay, so for the 20th day, we find in our device an encrypted file with the starfruit grove position in the jungle. So what we have to do is to decrypt this file and meet up with the elves there. Luckily enough, we remember the algorithm for encryption, so it shouldn't be that hard to decrypt the file and get the answer. So basically how this whole thing works is that we have a circular sequence of numbers, and each number will have to move in one direction, um, forward or backwards in this array. And the way this mixing works is that, for example, if we have the number 1, it has to move in the forward direction for one step. If we have a negative number, it has to move backwards that amount of steps. And yeah, basically we have to go through each number once and move it in its correct position. And for the answer, pretty weird, we have this 0 number in the list which doesn't move, and we have to find the 1000, the 2000 and 3000 number after this value, after this 0 value, and I think we have to sum these three numbers together, and that would be the coordinate of the grove. Then for the second part, of course, we need the decryption key, so we have to multiply these numbers with this number, pretty large number, and we have to apply like the mixing algorithms 10 times on the numbers. But yeah, I guess the trick here is that after the first mixing, the numbers will have some other ordering. They won't be in the original ordering. But when we apply the second mixing, we have to use the original ordering of the numbers. So basically how they say this in this example is that if the negative 3 value appears fourth in the original list, then even after 100 mixing rounds, we still have to move this minus 3 value on the fourth move. So yeah, I guess solving this wasn't as hard as it first seemed. So we just read the input as a vec of numbers. These numbers were split by lines, so split everything into lines and then parse them as an I size. Then I have this mix function that will take as input a vec that we want to mix and the order of the numbers. And the issue was that the numbers are not unique, so if they tell us, okay, the minus 4 number will have to be moved in the same order as it appears in the original list, but if there are two numbers like that, then which one moves first? So to alleviate that problem, I also included next to the value, I also added an U size value that will represent the original index of that number. So we have to go through all the numbers in order. Then we have to find that number in the mixed vec. So we use this position function that finds the first appearance of the x value. Then we compute the index where we want to move this current item, and that would be basically the index in the array plus its value, and then we have to modulo everything with the length of the array minus 1, because we would remove the item first and after that we move it, so we have to subtract 1 from the length. Then we just remove the item from the list and insert it to the new index. So as I said, first we modify the input to contain its original index as a new size. So we apply enumerate on the input and construct this tuple of the index and the value. Then we initialize the mixed vec as a clone of the input, and for the first part we apply mix only once. Then what we have to do is find the 0 value, so we search for 0, and after that we look through the vec and try to search for these indices, and we add these values together. For the second part, we do pretty much the same thing, but we have to multiply the value with this number as it's said in the statement. Then we still do the clone for the mixed vec, and then we apply mix for 10 times on the input. And then again we search for the 0 value and do the same sum as before for the indices 1000, 2000 and 3000. And yeah, this was the 20th day. The statement made it look more complicated than it really was, but yeah, I guess you can find the source code in the description if you want, and see you guys next time. Bye bye.